Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Please, if you know you have not subscribed, please subscribe to support my work on YouTube. Is that okay? You are going to look at change of variable. Change of variable. So another change of variable. In fact, you have equation with constant coefficient and equation with variable coefficient. But first, you are looking at the equation with constant coefficient. Now, for the change of variable, let's consider the first order linear differential equation with constant coefficients given by this, where a, b, c are all what? Constant. Now, the change of variable is that we just change the coordinates. Is that okay? We're going to change the coordinates. So when we change the coordinates, we rotate it. So the x, we rotate it to the top, and the y also keep on rotating. As it rotates, that's where we are getting the x and the y. And there's a new variable here called xi and eta. Xi and eta. But this is the variable we are going to use a lot. And there will be an angle forming called angle what? Alpha. There will also be an angle forming here, also called alpha. Okay. Now, for us to find the angle, we use tan. So tan alpha will be equal to b over a. B over a. This is the point or the constant you are talking about. B over a. So the b and the a are the constants. Now this xi is defined as this. The eta is also defined as that. So the xi is defined as a cos alpha plus b sine alpha. The eta is defined as negative x sine alpha plus b cos alpha. Is that okay? Now we are going to use chain rule to differentiate this. Is that okay? Partially. But the way the question will give it to you, that's how you look at it and differentiate partially. So here, if I'm using the chain rule to differentiate this, first I'm going to differentiate this with respect to x. Is that okay? And with respect to x, we get u xi x plus u eta x. Then u partial with respect to y, we have u xi y plus u eta y. Is that okay? If you think you'll be confused in terms of the definition of these two, this is how you look at it for the. So here is xi, here is eta. You can draw this diagram. So that I have here x, here y, here x, y. Is that okay? So like when I take the first one, that will be u, that for the x side. So u xi x. Have you seen that? U xi is here, then xi x is here. Then you move to u eta is here, then eta x. But you also move to the y xi, u xi y, u eta y. Is that okay? So that is how you go about it. So you should know the definition of the xi and the eta, how to find the angle, and how to find or how to define the u subscript as the partial derivative with respect to x and with respect to what? Y. Now, normally this, when you work for the angle, the answer that you are going to get should be in radians. Is that okay? It should be in radians, so you should take note of that. Okay. Now let's look at example. Okay, so now let's look at the first example. Find the general solution of the PDE. Is that okay? So we are using the change of variable to do so. So the first one, you have to be able to identify your A. So our A is 1, our B is 1. The coefficient of ux is A, the coefficient of uy is B. Okay. For this one, it's not important. Is that okay? This is not important, like bringing this, because you only need the tan. You see that tan alpha is b over a, meaning that my tan alpha will be equals to 1 over 1. So here take tan inverse of 1, and this will give you pi over 4 radiant. That is tan inverse of 1 is 45. In terms of radiant, will be pi over 4. Is that okay? Yeah, okay. Now let's look at the definition of the xi. So that xi is equals to x cos alpha plus y sine alpha, and eta is equals to negative x sine alpha plus y cos alpha. Is that okay? So in this case, our xi will be equals to x cos alpha is pi on 4 plus y sine alpha is pi on 4. So we have xi is equals to cos pi on 4 is 1 over root 2, okay? So 1 over root 2 times x will be what? X over root 2. And this sine pi on 4 is also 1 over root 2 times y will be y over root 2. So this implies that xi will be equals to x plus y over root of what? 2. Is that okay? Then you also look for the eta. The definition is negative x sine pi on 4. For alpha is pi on 4 plus y cos pi on 4. So in this case, my eta is negative x over root 2 plus y over root 2. And this implies that my eta is equals to y minus x over root 2. Is that okay? So this is what we have now. Now, what we need to do next is that we need to differentiate this xi here with respect to, partially with respect to x and partially with respect to what? Y. And the same thing applies to the eta. You differentiate it partially with respect to x, partially with respect to y. So when I come to this place, xi with respect to x. Now if I differentiate with respect to x, then y would automatically go to 0. If I differentiate x, that will give me 1. So I have 1 over root 2. Xi with respect to y. If I differentiate this one with respect to y, x goes to 0. If I differentiate y, that is 1. This one to give me 1 over root 2. Then eta with respect to x. So here you give me negative 1 over root 2. Then eta with respect to y will give me 1 over root 2. Okay, from here. Now after this, you now move to the question where we have to differentiate this with respect to x and this with respect to what? Y partially. Okay, so this is what we are going to do. The ux, you know that if you are different, you become xi u xi x plus u eta x. Then u subscript y also u xi y plus u eta y. But I gave you a tree that you can use to do that. So if you can't memorize this like the way I'm writing, you can use the tree to also get the answer. Is that okay? Good. So let me clean the top one. So now when I come here, I have xi x, right? Xi x is 1 over root 2. Eta x is negative 1 over root 2. Then eta y is 1 over root 2. Xi y is 1 over root 2. So we are going to substitute that one here. So let's do that. So I have xi u subscript x equals xi x is 1 over root 2. 1 over root 2 times u subscript xi is 1 over root 2 u xi. Itai x is negative 1 over root 2. Okay, you have negative 1 over root 2 u itai. Is that okay? Then you also move to u y. So for the uy, xi y, you have 1 over root 2. So I have 1 over root 2 u xi, and itai y is 1 over root 2. So plus 1 over root 2 itai u itai. So this is what you are going to get for this. So you just come back to this equation, then you substitute this one there. So let me repeat the equation. The equation was u x plus u y minus 2 u equals to 0. So here u x is 1 over root 2 u xi minus 1 over root 2 u itai. Okay, so now I'm done with this one. Let me look at the u subscript y. That one is also plus 1 over root 2 u xi plus 1 over root 2 u itai, then minus 2u equals 0. Is that okay? So in this case, this and that are the same, so they will cancel out. This plus this will be 2 over root 2 u xi equals 2u. Is that okay? Now here, if I multiply both sides by root 2, so I'm going to have, and divide here by 2u, I'm going to have u xi over u equals to root 2. I hope you understand. This is algebra, so let me write it here for you. So this implies that u xi over u is equals to root of 2. So that's what you are going to get. Now from here, let's integrate this. Remember, this is u xi, means that you are integrating this with respect to xi. Is that okay? If I integrate this with respect to xi, if you integrate this, this will give you a function in derivative. So this will give you ln u. Is that okay? Good. It's equals to root 2. This is a constant with respect to xi, so root 2 xi plus ln of. Now remember, this partial differential, and you are dealing with xi and itai. So if I differentiate or integrate with xi, the constant becomes the itai. Is that okay? All right. So now from here, I can write this one as ln of u minus ln of f of itai equals root of 2 xi. So this is u over f of itai equals root of 2 xi. Is that okay? Good. So let me clean the top. Yeah, if I take e on both sides, I'm going to have u equals f at itai e to the power root 2 xi. Is that okay? When you take e, then you multiply here by the f itai. So this is what you are going to get. Is that okay? Okay, so now this is what we have. But in the question that was given, there was no xi and there was no itai. So you need to do back substitution. So you remember the xi, we had this, the itai, we had this. So you're going to substitute this one wherever we see itai and wherever you see xi into this equation. So I have my u equals f. Now the itai here is y minus x over root of 2 e root of 2 multiplied by xi, which is x plus y over root of 2. Now, f y minus x over root 2. Now, this root will cancel this one. So, I have e to the power x plus y. So, this becomes the general solution to the problem. So, you should understand the procedures that I went through. You need to know the definition of the xi, the definition of the eta, how to differentiate the u subscript x with the chain rule we are using, the u subscript y, how to do that, and how to do the substitution. Okay, let's move to another example. Okay, now let's look at the second example. Solve 3ux plus root 3uy equals 1, subject to the initial condition, that's IC. ux0 equals x squared. So, if you want to solve this, first you have to be able to identify your a. So, my a is 3, my b is root 3. So, tan alpha is b over a. So, that will give you tan alpha to be root 3 over 3. So my alpha will be tan inverse of root 3 over 3. So let's see. These are going to give me, that's 1 over root 3, right? That has been rationalized to be this. So it means that it will give you 30. And 30 to radians will be pi on 6. Is that okay? So this is what we have. So now let's define our xi and our eta. So our xi is x cos alpha plus y sine alpha, and our eta is negative x sine alpha plus y cos alpha. So let's do the substitution. That equals to x cos pi over 6 plus y sine pi over 6. So x equals cos pi over 6. Now cos pi over 6 is what? Root 3 on 2. So root 3 on 2 x sine pi on 6, sine 30 is half. So sine 30 is half. So 1 over 2 y. So this implies that my xi is root of 3 x plus y all divided by 2. Is that okay? And my eta is negative x sine pi on 6 plus y cos pi on 6. So my eta is equal to, this is half, right? Sine pi on 6 or sine 30 is half. So this will give us negative 1 over x over 2x plus cos pi on 6 is root 3 over 2y. So this implies that my eta is going to be root 3y minus x over 2. Is that okay? So this is what I have. Now let me write these things down somewhere here. The xi I had root of 3x plus y, because I'll use it later. That's what I'm writing there. Then eta I have root 3y minus x over 2. I'm going to use it later. Now if you look at this one, First, let's differentiate the xi with respect to x. If I differentiate this with respect to x, this y will go to 0. Then here x will go to 1, leaving root 3 over 2. If I differentiate the xi with respect to y, what is y? Y will go to x will go to 0, everything here will go to 0, y will be 1. So we have now if I also get itai with respect to x, that will give me negative 1 over 2. Then xi with respect to itai with respect to y, that will give me root 3 over 2. Is that okay? So this is what we are going to get. So now, the question given, this is 3ux plus root 3uy equals 1. So let me rewrite the question. 3ux plus root 3uy equals 1. So we are going to differentiate this. Please, as I move on, sometimes I will not do it separately. I will just put it inside straight away. But this one is what? U xi x plus u itai x. Okay. Then u y is u xi y plus u itai y. Means that I'm going to put it straight. So 3 bracket open. Ux. This is my ux. But remember xi x is what? Xi subscript s is root 3 over 2. Root 3 over 2 times this will give you root 3 over 2 u xi plus eta x. This one is negative half. So here will be negative 1 over 2 u itai. That's how it's going to look like. Then when I come here, plus root of 3 bracket open u y xi y. This is xi y, that is half. So half u xi. Then itai y. Itai y is root 3 over 2 u itai. So this is what we are going to get. So I'm going to expand this. 3 times this will give you 3 root 3 over 2. So 3 root 3 over 2 u xi. 3 times this will give you negative 3 over 2 u itai. Then root 3 times this will give you plus root 3 over 2 u xi. This one was equals to 1. Okay. Then this time this will give you root 3 times root 3 will be 3. So this will be plus 3 over 2 u itai equals to 1. So you could see that this and this are the same, so they will cancel out. In fact, anytime you do it, one of the either xi or the itai will cancel out. So you should take note of that. Now let's add this one to this. You remember this is 3 root 3. This is root 3. So the radical signs, they are the same. This is root 3. This is root 3. So I can add it. That will give you 4 root 3 over 2. Is that okay? And 2 can go into 4 2 times. So at the end, I'm going to have 2 root 3 u xi equals 1. Is that okay? Now let's divide both sides by 2 root 3. So here is going to give me u xi equals to 1 over 2 root 3. So we are integrating it with respect to xi. Let me clean this one. So if I'm integrating this with respect to xi, if I integrate this with respect to xi, I have u here equals to 1 over 2 root 3. Let me conjugate this one. 1 over 2 root 3 times 2 root 3 over 2 root 3. This will give me 2 root 3 over 4 times 3. 2 goes here, 1 go here, 2. This will give me 2 root 3 over 6. So when I conjugate this, I'll get root 3 over 6. So here will give me root 3 over 6. So with respect to xi, so here will be xi plus f of what? Eta. Is that okay? Now, we want it in terms of what? X and y. So here will be root 3 over 6 multiplied by our xi is root 3x plus y over 2. So here will be root 3x plus y over 2 plus f of our eta is root 3y minus x, root 3y minus x, all divided by 2. So this is what we are going to get. Is that okay? Okay, now let's use the initial condition. The initial condition was given as x0 equals x squared. The meaning of this is that u is x squared. Okay, so wherever I see u, I put x squared there. So let's see. Here is going to be x squared equals root of 3 over 6 bracket open. X is still x. Okay, so wherever I see x, I repeat x. Y is 0, so if I put 0 here, it will still be 0. So let me forget about that one. So this is what I'm going to get, plus f bracket open. This side y is 0, so here will go to 0, leaving negative x over 2. So here, if I do the multiplication here, root 3 times root 3 will be 3. Okay, so that I have my x squared equals 3x over 6 times 2 is what? 12 plus f at negative x over 2. Is that okay? Okay, so this was our general solution. Okay, so is this one that I have substituted the initial condition, and this what I have now. So here I'm trying to make, the f at negative x over 2 the subject. So in this case, 3 can go into 12 4 times. Okay, so if I bring it here, I'm going to have f at negative x over 2 to be x squared minus x over 4. Is that okay? Very good. So here he said that let p to be equals negative x over 2. Okay, so in this case, our x will be negative 2p. Is that okay? So you come back here and substitute f at p is equals, wherever I see x, I put negative 2p there. So negative 2p squared will be 4p squared. Now, already there's negative here, so if the negative come to this place, again I get so I have positive 2x over, positive 2p over 4. So the 2 go here 2 times, so that will be p over 2. Is that okay? So this is what we are going to get. So now that I have this, I'll come back to this place. Okay, that f there, that's what we want to remove. So we have f bracket open root of 3y minus x all divided by what? 2. Is that all right? Then I equate this one. It means that when I come to this place, wherever I see p, I'm now putting the whole of this there. So this place becomes 4 bracket open root of 3y minus x all divided by 2 squared. Okay, plus so this p will be root of 3y minus x all divided by 2. And remember, The p here too is divided by 2, so divided by 2 like this. So what it means is that if I open a bracket here, what I'm going to get is that this 2 square will give us 4. 4 will cancel this, leaving root of 3y minus x squared. Is that okay? And also, due to the division, these two multiply this one. So I have plus root of 3y minus x all divided by 4. Is that all right? Very good. So we are just coming back here, and the whole of this is now all of this one. You can see that. So this is how it is looking like. It's now going to be root of 3 over 2 bracket open root of 3x plus y over 2 plus, now the whole of this is now all this. So I'm going to have root 3y minus x all squared plus this one, which is root 3y minus x over 4. Is that okay? Very good. So this becomes our particular solution. And this is our general solution. This one is our general solution. Is that okay? So please, you should take note of this. I think it's very simple.